Good evening, everybody. Welcome to the Institution of Engineers Sri Lanka. My name is Arjuna Manamperi, Chairman, Mechanical Engineering Sectional Committee. Every month, at least, we have about 2 or 3 lectures of interest. Sometimes they are on public policy, sometimes they are on engineering, but the bigger picture, and sometimes we get down to the nuts and bolts of engineering, which is pure engineering. Today's lecture is live streamed as we speak. From the very moment I get up here, we are live streaming throughout the world to our members. We have about 14,000 members who are members of the Institution of Engineers Sri Lanka. And these videos are all recorded digitally. And for the last 2.5 years, we have been archiving them and making it available to those of our members who want to see it again and again. Today's proceedings goes like this. We will have a presentation, main presentation for about 45 minutes, not more than that, and then we'll go into a panel discussion. You can ask questions. I will be moderating the panel. We'll have some panel members. I normally don't take a lot of time to introduction, so straight away I would like to go into this topic. I think this is a very relevant topic. About 2-3 weeks ago, we had another lecturer here from Australia, Sri Lankan of course, Professor Atula Ginige, who did big data gathering using mobile telephones and etc. with our farmers, but of course he lives in Australia. His work was with our farmers here, and later he moved that experience into railway transport system in Sydney. So this year my plan is to promote 2 or 3 themes, and big data and how we can use it to change our environment, our society, our work ethics, etc. is a big thing, and I think we should be embracing that. So I think this is a very good lecture along those lines. Very few people, if they pay attention to what's happening in the public forums, will need the introduction to our main speaker, Dr. Rohan Samarajiva, who happens to be a colleague of mine as well. Rohan will be the key presenter, and then he will be joined by Dhananjay Maldenia, one of his colleagues from LERN Asia, to part of the presentation. And then Rohan will come back again within these 45 minutes. So it's first Rohan and then Dhananjay, and then Rohan will come back and wrap it up, and then we'll immediately go to a panel discussion, which is the most interesting part. So without any further ado, Rohan, podium is yours. Please welcome him.
Good evening. I'm very grateful to Arjuna and the Institution of Engineers for arranging this talk. This is the first public airing of this research in Sri Lanka. We've had opportunity to present it in other countries, but this is the first time we're actually presenting it in Sri Lanka. This is a multidisciplinary enterprise, and I would like to acknowledge at this point my colleagues Sri Ganesh Loganathan and Dhananjay Maldenia, as well as Kaushalya, who is not here, and Professor Amal Kumarage, who've been working with us on this topic. Okay. What's the, I go like this? No? Thank you. Right. I just use this, right? Okay. Right. So we actually have data from Sri Lanka, and this is, well, before we get to the big data, let me talk a little bit about the organization, LERNeasia. This is our mission statement. We don't believe that we do anything by ourselves. We like this concept of catalysis, so that we like to get things started and have other people participate. And this is what we do, focus on hard and soft infrastructures through the use of knowledge, information, and technology. We are based in Sri Lanka. The only office that we have is in Sri Lanka, but we work throughout the region. These are the countries that we work in. And as far as big data is concerned, we have been working only in Sri Lanka in the exploratory stage, 2012 to 2014. We hope to extend to Bangladesh and Bhutan in the next cycle. Smart cities. Let me begin with this new buzz phrase. IBM has been promoting smart cities and big data since the 2000s. Cisco has been talking about it. But there are two visions. One vision is of new smart cities created on green fields, like South Korea's Songdo. I have not visited this location, but I have talked to people who are working there at this time. And that is a case where they have embedded a lot of sensors. Even every parking space has got a sensor. There's huge amounts of sensors built into the concrete, built into the physical infrastructure of the city. The other, of course, is that we could focus on improving the functioning of existing cities. And that is our focus. Now, one of the reasons why the smart city concept got a lot of mileage and attraction is because Prime Minister Modi, when he came into power, he promised that they would create 100 new smart cities. And I was sort of thinking, well, maybe our guys can take a piece of that action from Sri Lanka, because that's the advantage that we have. Our software skills, our agility, and our nimbleness. However, what it looks like is that they're going for this greenfield option, where they are thinking not of fixing the existing cities, but of creating sort of satellite cities that will have a lot of this technology built in. And of course, a cynic would say that that will sell a lot of equipment for the various companies that are promoting, but I'm not a cynic. Now, when we take Colombo, I believe that we have to focus on the second option, and we have to improve the functioning of Greater Colombo. To a certain extent, we tried the greenfield option, which is the city was expanding north and east, north and south until the 1980s, and with Sri Jayawardenapura, we pushed eastward. And we are still trying to sort of figure it out, because we haven't really moved all our government officers over there as was the original intention, and there were certain negative aspects of that. For example, the filling of the wetlands and so on. There are some possibilities that are now being discussed with the 3 Ks, Kadawatha, Kaduwela and Kottawa, which have to do with the outer circular highway and the ramps that are coming down from that. And there may be possibilities of doing greenfield solutions in those areas. But I think we are relatively small. Even when we take Greater Colombo, we are talking about 2 million people. And I think we really need to improve the functioning of the city rather than think of these little enclaves here and there. Now, 5 years ago, nobody was talking about big data. Now everybody is talking about big data. The question we have to ask is why? And why now? There is one answer, which is that now there's a whole lot of schemaless data that is now available. And Victor Meyer-Schonberger, who's a prominent author in this area, has coined the new term called datafication. So this is not the old style databases, but this is things that can be converted into analyzable form. Advances in memory technology, for example, and of course advances in software. But in actual fact, you could argue that this is embedded in a much larger context that was first discussed by James Beniger in his book Controlled Revolution, where he looked at the application of ICTs, and his basic thesis is that there is a kind of a dialectic. There is at one point a crisis of control. In the United States, in the early stages, the transportation networks, we are talking the 19th century, the late 19th century, the transportation networks, the railways were developing, and they didn't have the technology to capture control the railways. So they came up with the telegraph and time zones. They didn't have time zones. So every city had its own time. So all these things, these what he calls technologies of control, were brought in to control and gain the benefits of the new advances in production and distribution technologies. And as mass production brought down unit costs, another crisis of control emerged, which was that people couldn't get rid of all the stuff that was being built, being manufactured. And then we talk about another response, which is mass media and advertising in order to stimulate consumption and to more closely align consumption with production. Because a lot of the manufacturers were just producing without knowing whether there's actual demand for this. And now we could argue, this part is not Jim Beniger's. Now we could argue that the crisis is over a control over attention, that advertising is so pervasive that we are not paying attention to advertising. And they are now trying to use data analytics and micro-targeting of audiences to again gain control of the system. We could discuss this in political and other context if you wish during discussion time. So analytics have been in use within companies since the 1990s. Before I started work on regulation, actually this was my area of research, utility customer information, looking at what kind of access, what kind of knowledge could be extracted from electricity transaction generated data and telephone transaction generated data in those days. So those days they had to use supercomputers. And other than the NSA, which now everybody knows about, the other entity that was buying the supercomputers was American Express, who were running it over the credit card purchasing information that their customers were generating. In the 2000 period, you had IBM, Cisco, all these people coming in, and they really focused on the smart cities. Rio was the prototype in 2010, but there they were using mostly video and GPS. Now these models, as I said, rely on proprietary software and install for purpose sensors. Now my question is, can we have this on the cheap? I think yes. That is, we know that pretty much everybody in our cities has got a mobile. And every citizen who we are trying to serve, because remember in the end, we are trying to serve the citizens. Every citizen is actually a sensor. We are trying to improve the citizen's ability to move around the city. Why not get information from the citizen directly? So there are other options in places like Hong Kong and London, where I think you know there are prepaid travel cards that are quite ubiquitous. That is, you can use them for the metro, you can use them for the bus, you can use them even for purchases. I think there's some incredible potential in those. And I think we can, if we introduce such things, we can use that, of course. And I think we have quite a lot of open source analytics that my colleagues will be able to talk about during question time, and the hardware is not at all expensive. Now we need to think about what we are doing. We need to be careful. This is not a solution for every problem under the sun. So one of the most famous stories was Google flu trends, where Google said that based on how people search for flu-like symptoms, they could even predict the spread of influenza in the United States. And then it was found that people changed their behavior. People don't behave the same way, and now that particular indicator is broken. It doesn't work anymore. And there are problems of representativeness. In statistics, we always worry about representativeness. There are some of us who think that representativeness is no longer an issue with big data. But I will say that there are some issues. Now this is one application in the United States, in Boston, called Street Bump. This is one where people can download an app from Google or from Apple and put it on their smartphones and put their smartphone in their car and drive. And they just have to press one button as the car starts, and when the journey is over, they press another button. When they press the first button, the app starts working. It collects all the GPS data, the location, the road, and it also collects information about all the bumps. That's why it's called Street Bump. All the potholes, the bumps that the car went over. And at the end, when the person presses that second button, it transmits it to the data center. And they have an algorithm which says, if we have this many reports from citizens about these particular roads, and we look at the outliers, etc., etc., they have an algorithm, we will know that that particular road has got an unacceptable amount of potholes, and we should dispatch our vehicles to go fix it. Seems like a wonderful program. I mean, this is big data, this is crowdsourcing, this is involving the citizen in the running of the city. All the key buttons, the emotional buttons are hit in this particular solution. But we have to understand that not all of our people have smartphones. These are some of the countries that we work in, and you can see that we don't have data about smartphones per se, but you can see from the sort of the proxy indicators of internet users and Facebook users that in actual fact not everybody has smartphones. So is there not a possibility that the roads in Colombo 7 or Gaul Road or whatever that are traversed by the rich who have smartphones will get more participation, and they will get more of the limited resources that the city has to repair the roads? And the areas in Mattakuliya and various other places may not get that kind of attention. So we are basically saying, let's be aware, let's be sensitive to these issues, at least now. Because in 5 years' time, I'm confident that everybody in Sri Lanka will have a smartphone. So at that point, this problem will disappear and some other problem will come up. But I'm just using it as an illustration to say that we should pay attention and think about this. So when we look at the smart cities, we were thinking, you can fit all vehicles with GPS devices, you can put electronic toll cards, you can do all kinds of things. But the important point is that this is already there. There's no additional cost. We will show you some cost comparisons as we move along. We are not using VLR data, which is, as you're sitting here, your phone would have communicated with the base station saying, hey, I'm here. You didn't do anything, your phone did that. We are not using that because it's very large, right? We are also getting into it gradually, and we use only call detail records. And we believe that much can be done with CDRs, which is, I'll tell you what the CDRs are covered. Now, we can take these mobility variables, that is over there, these mobility, that is the value of mobile data is that it tells you how people actually move. We have social variables, that is who do they call, which areas do they call, and consumption variables. More than 92% of our customers are prepaid, and their loading frequency, etc., can give us some indication as to their consumption. We can combine it with these data. One of my favorite government resources, household income and expenditure survey, 25,000 sample. It's a wonderful data set. It just takes a long time for it to come out, but I would recommend that everybody look at that. And survey maps and transportation schedules. Not very useful in Sri Lanka, but and then we can have insights for all these things, which we will talk about as we go. So what have we used? Our mobile operators, multiple operators, have provided us kindly with 4 different types of metadata. One is called the detail records, that is who made the call to whom is all recorded for billing purposes. Which base station, for how long, things of that nature. Now, we don't get any of this individually identifiable information. All that is pseudonymized, right? That is covered. We get a random string of digits that has been that replaces both the numbers. So don't worry about us knowing anything about your calling behavior, right? Every time somebody does an SMS, the same kind of activity happens. For billing purposes, they generate a CDR. Internet access, you don't generate 2. In the other case, if it is done within the company, the receiving person would also generate a CDR and the sending person would generate a CDR. In the case of internet access, we generate 1. Airtime recharge records, we have not fully exploited this yet, but we have not used visitor location register data. As I said, we do not have any personal identifiable information. This is what we call pseudonymized. That is, we have replaced a number with another random set of random digits. Wherever that number appears, the set of random digits is the same. So we can look at patterns. Instead of true anonymization, where we would be putting different numbers for every telephone number. In the western and northern provinces, the ones that we are talking mostly about, we have 50 to 60% of the users in our data set. So now, Dhanaj.
Yeah, so I'll be taking you through some of the analysis that we've carried out, particularly with the mobility orientation. And one of the earliest analysis that we did was with regards to understanding how population densities changed over time in a given region. In the visualization that you see, what you actually see is the relative density, population density in a given in Colombo and the surrounding areas with respect to midnight. Areas without, areas without a particular color are areas where the density has not changed with respect to the density at midnight. Areas with either blue or dark blue are areas where the population density has actually decreased with respect to the midnight value, and areas with either yellow or red are areas where the density has increased with respect to midnight. And if you take, say for example, this particular visualization that shows the relative densities of the population densities during midday of a weekday, you see Colombo lighting up with much higher densities than during midnight, and the surrounding areas having much lower population densities than during midnight. In comparison, if you take a Sunday morning where people don't actually move about much, you see that most of the areas don't have a change from your density during midnight, and even the peak value in Colombo is not that significant. What you see here is the same result for Jaffna and Kandy, and in the case of Kandy, you notice that in Matale and in Gampala you see small hotspots during daytime. One of the things that actually shows the power of this kind of analysis is that the hotspots that we capture here correspond quite closely with the major destinations captured in the Comtrans surveys. Now, whereas actually in the case of our analysis, we actually capture that Ratnapura seems to be kind of a hotspot. Ratmalana it seems to be a hotspot too, whereas in the case of this case we probably actually don't notice it much. So maybe it's something that we might want to look into. While the Comtrans report with a whole host of other results cost around $400,000, the actual result here has an incremental cost that is practically negligible. And while it's not a very big leap to assume that, for example, during daytime, Colombo serves as a sink for the population. And in order to understand this better, we actually carried out a further analysis where we find out where people live and work. And how did we do this? We considered 4 months of data, CDR data, and we first established in the general mobility patterns of people. And from these, we established, okay, in general, these are the hours where people would be at home, and these are the hours people would be at work. Basically, time slots for home and work. To identify which DSDs a person may be most located at. During the home hours, it would count towards home, and during work hours, we would estimate this to be work. So what do these results look like in terms of Colombo? The first thing that we notice is that nearly 50% of Colombo city's daytime population comes from the surrounding areas, with Maharagama, Colonna and Kaduela leading. Now in 2011, the government proposed that we have extended municipal boundaries along these DSDs. But our research seems to suggest that Maharagama may be a candidate for the boundaries as well. So what are the implications of this for public policy? One thing that comes to mind is that perhaps the boundaries that we have, the municipality boundaries that we have, are outdated. And the results that we've generated provides a logical means of redefining these boundaries. In terms of transportation policy, it is of interest to us to understand where the high volume corridors are, so that we can set up maybe mass transit. Now, the Kaduvilla DSD, which was number 3 in terms of sources to Colombo city, has already been identified by other means as such a candidate. The high level road, on the other hand, the Maharagama DSD, is indicated by our results to be a possible candidate too. So let us move on to a rather interesting case study of how people actually move about during Aurudu. Now, we considered Aurudu during a particular year where Aurudu actually fell on a weekend. So we actually carried out analysis based on 9 weekends with Aurudu in the middle. The first thing that comes to that we realize is that while on average the average distance traveled by people during a weekend is around 11.6 kilometers, during Aurudu this actually is about 45% time higher. In order to understand this increase, we plot out how these displacements have occurred in terms of distributions, and you see in blue the distance distribution before the week before Aurudu, in green the distance distribution after Aurudu, and in red the distance distribution during Aurudu. And you will realize immediately that at greater distances, Aurudu people have actually traveled longer distances more, and in terms of shorter distances, there have been less people who have been traveling shorter distances. So where have people been traveling during Aurudu? What you see here is a visualization of inflows into DSDs, where moving towards color red, you see cases where people have traveled more with respect to other weekends. Towards blue, you see cases where the inflow into the DSD is either equal or less than during other weekends. If you just take Colombo city, other than the Ampara DSD, flows into other DSDs from Colombo have increased. If you just take a sample, for example, the flows during Aurudu is 315% times greater than on a regular weekend, and similarly to Trincomalee it's 100% times greater. To Jaffna it's more than 80%, and so on. I think Rohan would be taking over from here.
So one of the things that I think many people were surprised about is how small Colombo actually is. It was 650,000 people in the previous census, and the last census showed that it's 550,000. What is happening? Is Colombo becoming smaller? So we thought we'll try to shed some light on this phenomenon. We looked at the hourly loading of base stations, and this is the first cut that we got, which is the peak is at about 12 noon, and this is Saturday and this is Sunday, and the peak is at about 7 p.m. and not much different from Saturday and Sunday. I think you know what this might suggest. This is a residential area. This is more has a commercial signature, which is very different usage patterns on the weekend and on weekdays, and this is primarily a residential area. So we we started with these two, and our team did things that I have no understanding about, unsupervised machine learning techniques. What is this? PCA, Principal Component Analysis. This is an interdisciplinary team. I am the social science guy in this team. These people are the technical people. And they identified, using these 15 principal components, they identified the base stations into 3. Originally into 2, but then they moved on to 3. So when we analyze it in terms of 3, this is the picture that we get. That is, you can see that this whole area is red. That is consistent with a commercial area. And you have red touches here and here and here, right? And the blue is the base area, that is more consistent with residential, and the green is the mixed case. So we now sort of zoom in on the city of Colombo, on the official boundaries of the city of Colombo, which is the divisional secretariat divisions of Timor-Leste and Colombo. That's the city of Colombo. So this is the city of Colombo, where 550,000 people live. Now you can see that quite a lot of it is covered in red, and some of the red spills out onto this side as well. So that is our old commercial center, the fort. And after all the suicide bombings and the roadblocks and all the punishment that that area took, quite a lot of the commercial establishments moved down to Nawam. And you have things like the HSBC call center that was set up, leading to this area being converted, even though outside the city being converted. Now I expected this line, which is Nugevada, to be more of a commercial area, but it looks like both these areas are developing as commercial corridors. So we were kind of intrigued when we first saw this. I'm sure somebody knows what this is. So what the hell is that? That is in the corner of the district of Colombo, and it's a very rural area, you know, that's Avissaville, right? It's quite remote and mountainous, and I mean, you're there and you can't even tell whether it's Colombo. So I told these guys, go find out what it is. The answer is Sitavak Export Processing Zone, which I personally didn't think was a great success, but I have been informed and educated through the research that in actual fact it seems to be a place that draws people in on the weekdays to work, and that people go away during the weekend, and it has a commercial or industrial signature. So we looked at some of the intermediate areas and said, how do we know these are the greens, which way are they trending? So when it's a blue, that means it's trending towards residential. When it's a red, like here, we could expect that within the next few months or a year, this will be colored red. So this, in fact, is the answer to the little puzzle that some may have had about why Colombo's population is decreasing. Because more and more of Colombo's residential housing stock is being converted into commercial establishments, and people are moving out into these areas to live, which is not unusual. So these are the plans, and this is the reality. So this yellow in these plans, this is the UDA's 1985 plan, this is the 2020 plan. They wanted these to be primarily residential. Like facts have overtaken the wishes of the planners. So what we believe is that this gives us a very easy method of almost real-time monitoring of urban land use. We would like to get more nuances, you know, entertainment zones and things like that. And we could use this to align the master plan. We had, now my own office used to be a house and now it's an office. And I think we had some people come and ask us when we had converted into an office and so on and so forth. But I think we'll be able to get it from this kind of data without sending people out with questionnaires. Now this is, all this time we were using sort of proxies, right? Now the second one was not a proxy, that's the first best. The loading of the base stations is what we need. In the first ones we could say that the VLR is the first best, and we are using CDRs because it's easier to get, because you must understand the companies don't even store and record and keep the VLRs. There's so much data right? So they just flush it every 15 minutes. So to get that data is heroic effort on our side and on the company's side. So we prefer to work with CDRs. But in this case, where we are looking at communities, we are actually using the first best, which is who is calling from which base station, not who is calling whom, but who is calling from which base station to another base station. The calling patterns between base stations. And the answer that we get is that Sri Lanka is made up of 11 communities as signified by their calling patterns. Now, you saw the mathematical formula earlier, but basically, in simple language, a community is one where you communicate more within the community than outside. It's a very simple definition, which we have converted into mathematical form. So what we found is this. So we superimpose this on top of the existing provincial boundaries. And guess what? We get a very interesting picture. The northern province is a community. It more or less, can you see? It more or less maps with the, there are 5 districts here. It more or less maps with the administrative boundary, as does the southern province. And you can say these are the 2 that are furthest away from Colombo, except Ambilipitia, as many people would know, is very tightly integrated into the southern area. So Ambilipitia is sort of taken by the southern province, and possibly this is Kataragama, also taken by the southern province, right? Uva Vellassa, I expected it to be separate, because even though we call it Uva, traditionally it has been 2 different places. One has plantation workers, the other has mostly Sinhala people, mostly peasants, rubber cultivation versus tea and all that. But you can see that in fact it kind of maps with, it has become a community over time. What I find the most interesting is Trincomalee. Trincomalee, now remember Mr. Prabharan wanted this whole thing to be one unit. But we can show that it's actually 3 different communities. It's not one. This is one. This is Trincomalee. It has its own existence. It has its own relationships. And this is the Batiklo and Ampara DSTs. What is most interesting, now you don't see it because we use a deep blue color, is that it connects to Purannaru. And if you think of the economy, now I have to tell you, up to this point, this is based on real data. My explanation is based on speculation, because we don't have a systematic answer to why. Purannaru, if you think Purannaru and this area, this is the rice belt of Sri Lanka. The most productive rice lands are here. The combined harvesters move through this area all the time. The rice miller integration between this area that is primarily Sinhala, Tamil and Muslim. So I think there's some very interesting possibilities of looking at this, and we can push this further. We can take a single province and break it down even further and so on. So that is the more or less the end of that part of the story. I will just talk about some policy issues at the end. One of the most important things, I'm happy that Amal is still here, is that this is a radically different kind of work. We cannot do it with a single disciplinary focus. We cannot do it with 1 or 2 people. I've been telling these guys, we will get to a situation where all the publications will have 10 authors, like in chemistry and physics and fields like that. That this will be an area like that. So these are the people that we've been working with. Sri Ganesh is here, Kaushalya and Danaja, both graduates of Moratua. Dedunu Dhananjay has now moved on to industry. Again, data scientists are very much in demand. So we don't expect to be able to hold people for very long. Nisansa did some extraordinary work with us, but now he's a PhD student at University of Oregon. We've had people from MIT come and work with us. We don't give the data out, so the data remains here. When they want to work on the data, they have to come here, and they have paid their way to come and work with us. We have had the assistance of WSO2 and of Carnegie Mellon. And on the transport side, Amal Kumarage, on computer science and engineering, Amal Shehan Pereira. We have undergraduates from Moratua who are working on some carved out chunks. And we've been fortunate to be able to work with one of the leading researchers in this area, Joshua Blumenstock from the University of Washington, and Saad Gulzar. So when we are looking at, I will just conclude in the few minutes that I have, when we are looking at this problem, we looked at what are the challenges, because we went into this not knowing what we were getting in for. Foolhardiness is an asset in starting a new field. One of the biggest problems that everybody is facing is negotiating access to data. The companies are very worried about giving the data because they think that there's a competitive advantage to them that might be harmed by giving it to others. They think some competitive disadvantage might flow to them because their competitors get to know about their network structure and their usage behavior. So we generally ask for multiple operators and we mash it up so that nobody can quite tell whose network we are talking about. They are very concerned about the possible public relations disasters that could come about if this data is misused. So we have signed extensive non-disclosure agreements, and basically every single slide here has been approved by the people who gave us the data. This is not the way we normally do research, but given that it's the early stages and we are trying to get people comfortable, we have agreed to everything that was asked of us. We have to assemble interdisciplinary teams that are superior to what the consultants can offer, because all these companies are getting consultants parachuting in with proprietary software. They say, you want to know churn? I'll give you churn. And they give you churn and they go away. And the company has no idea what has been done. What we are saying is, we are in the university model and we'll exchange ideas with you and we'll share knowledge with you. So we also believe, I don't know whether you know that after the Ebola crisis in West Africa, the Economist newspaper, which is generally very pro-market, very much against government intervention, actually demanded that the mobile operators be compelled to give mobile network big data so that research could be done to help deal with the Ebola spreading. Because you must remember, when diseases are spreading, this kind of data can be extremely valuable because it gives you information about how people move around. Or you could get proxies from how people call to whether people are actually moving around based on the calls that they make. So what we are saying is, let's be proactive and develop this research for public purposes and also develop self-regulatory guidelines, and let's build on that basis so that when the governments come calling, they will be able to respond proactively rather than reactively. So this is some little work that we have done on third-party use. Our objective was to reduce the transaction costs of releasing mobile network big data to third parties for public and commercial purposes. And we have discussed it with the operators, and we will continue to discuss it. This is simply a draft. The method that we used was looking at the literature where under common law, without working off big principles, abstract principles, you look at the common law where people have actually suffered harms and have gone for tort remedies under common law. So we looked at that, and based on that, we identified, I use Daniel Solove, who's one of the leading figures in privacy law these days. I used his work where he says we can't have a definition of privacy. For example, in the United States, even abortion is seen as a privacy issue under US law, the Griswold versus Connecticut case. It comes under the privacy label in US law. So he says we can't do that. We have to work with with what has been identified as possible harms. So he identifies 16 privacy problems grouped into information collection, information processing, dissemination, and invasion. Invasion is the one where you have, whether a doctor allowed somebody to stand in when a patient was being examined and things like that, that have no bearing on the kind of privacy issues we are dealing with, which is about data. So excluding that and a few others, we brought it down to 9 problems, which are surveillance, aggregation, identification. Insecurity is where the company has some safeguards, but it gives it to a third party, and that entity doesn't have those same safeguards, with the result that the data security is breached and harm is caused. Things like that. And also I looked at anti-competitive effects, because in a value chain, if got this information and is giving it only to its affiliates and is depriving the others of getting it, there can be competitive mismatch between those at different points in the value chain. So that is also an issue. And the last one is marginalization, which we really have been able to sort of come up with guidelines. This is the fact that some people are not counted, which is the smartphone story that I told you about. Some people have smartphones, they are counted, they are paid attention to. Other people are not in the data universe and they are excluded. Whether that's a good thing or not bad thing, we can discuss. So these are the remedies that we have talked about. For example, active surveillance, which is what Verizon and a few other companies have done, which is they have added additional headers to gather more information about their users. So that is, earlier we are talking about information that is needed for the operation of the company. Now here they are additional. So we are saying you don't have to include it in your agreements, the non-disclosure agreements, but this is something you need to think about, because it will harm the trust that your customers have in you, as Verizon recently found out. De-anonymization is a serious issue, and we don't think, there are some who say everything can be de-anonymized. No, that is overreach. We are saying this is going to be like a war, like an arms race, de-anonymizers versus the anonymizers, and we should have working groups to deal with it, because it is critical to all the safeguards that we put in. For example, we do not deal with data that is not anonymized or pseudonymized. Individual identification, again, this is not something we deal with, but even for public purposes, we could have a situation where, in the case of Ebola or dengue or something like that, there may be interest in having identifiable data, and how does one deal with that? And security, yes, as I told you, we believe these safeguards need. This is increased accessibility when the data is released to third parties. As you see, what you see is not the data. You see aggregated pictures. But if the data is made available, will there be any dangers? Anti-competitive effects, there are issues that we need to apply the basic laws of competition laws to this. And as I said, we don't have anything on the marginalization issues. That is my presentation. I hope we will be able to shed more light on this through the enlightened discussion that I expect from this audience. Thank you very much.
This message is for those of you who are watching us live stream. In about another 2 to 3 minutes, we'll have to stop this live streaming, because the panel discussion will not be live streamed today. Normally we do, but today's one will not be live streamed. We will begin the panel discussion now. You may stop this.